Good afternoon, everybody. Thank you all for being here. I'm glad to be here in Barcelona myself, so I'm sure you're enjoying it yourself as well. My name is Lars. I'm from Bluebee, a company specialized in high-performance genomics. So we enable solutions that would help partners in the field develop and run genomics pipelines in practice, reducing their overall cost, and also enabling faster diagnostics for patients. In this presentation, I will discuss our genomics pipeline that we're developing and a platform that enables doctors, hospitals, clinics to use genomics and run genomics pipelines easily in practice. I will start with an introduction of the company Bluebee. I will go ahead and discuss our platform itself, and then I will end with a use case description of how we enabled one of our customers to solve their problems and challenges in the field. So Bluebee is a spin-off of two universities. We're a spin-off of the Delft University of Technology in the Netherlands and Imperial College in London, Imperial College London in the UK. We develop a platform that enables fast, secure, and affordable DNA analysis in the field. We started the company because we saw the evolution that is going on in the genomics world. We saw that the players in the field are generating more and more data and facing more and more computational challenges that would represent a bottleneck of using this data actually to treat their own patients, to use it in practice. So we would like, from our background, our experience in computation, to enable people in the field of personalized medicine be able to serve their customers, their patients, in a faster and more effective way. We bring this together by combining a number of different characteristics or aspects from the high-tech field. So we work in the HPC field, high-performance computing field, bring our expertise to the game, and we work enabling cloud solutions or as well as on-prem solutions for the genomics environment, and also bring together some of the expertise that are being developed in the field of genomics itself from practitioners of using genomics data in a clinical environment, and combining all those together, of course, and ensuring security, privacy, and data integrity for the end user. Now, in any of these different pillars, we are bringing together different players from the market in order to bring all these expertise together to present and develop our platform. So from the HPC solutions, we have access to the research going on in Delft University of Technology, of course, and a number of other universities in addition to Imperial College London. With regard to cloud computing, we have a partnership with IBM SoftLayer to be able to deploy our solutions globally, and also from the genomics point of view, we have access to a number of different leading players in the field that access our solution and also give us insight into their needs so that we can develop our solution effectively. So we're talking about the Pasteur Institute from France, we talk about the DKFZ from Germany, or UMC Utrecht in the Netherlands, and others. To add to that, we also have a very strong technological collaboration with a number of different players in the field. Specifically with IBM, we have very close collaboration with a number of the research centers in the world, and one of a distinguished member of IBM, Peter Hofstee, is part of our advisory board. We are working very closely developing on Power 8 solutions and hopefully on Power 9 solutions. We were an early stage developer on Power 8, using, in addition to their standard server, also developments for CAPI integration using acceleration to implement accelerated solutions specifically for genomics on Power 8, and also, of course, Power 8 SoftLayer user in the cloud environment. In addition to that, we use Aspera for data communication, as we know that the huge amounts of data being transferred back and forth between sequencing centers and between medical centers is causing a bottleneck in enabling the personalized medicine revolution from taking place, and by adding the ease of transferring data from Aspera to our platform enables us to do that faster. And of course, we are a firm believer in the community efforts that enables these kinds of solutions to come to practice. So that's why we are part of the OpenPOWER Foundation. Actually, we are leading one of the work groups within OpenPOWER, the personalized medicine work group, and we are trying to bring together, along with OpenPOWER members, a movement, creating a movement that brings together developers of technology as well as users of that technology to enable a specific solution in that specific application domain in practice. So, talking about our solution in particular, and how we use the OpenPOWER technologies to enable an increase in performance, I would like to discuss our main two axes developing our high-performance solution on our platform. So we use basically two different aspects that are more or less independent from each other, that can contribute to each other and increase performance for the pipeline. We use on the one hand what we call distribution, which is basically scalability, trying to enable those pipelines used in practice, genomics pipelines, to be able to use a growing and scalable computational infrastructure. Now, having this capability of increasing the amount of computation that you have on a scalable infrastructure enables you to increase the throughput that you're able to provide the users. So, for example, in a medical clinical environment, having more and more patients coming in requires having higher and higher computational capacity, and enabling scalability for the pipelines enables a specific medical center to increase their throughput transparently and enabling treating or diagnosing more patients as they demand. Now, the other aspect of our performance improving capabilities depends on acceleration. We use what we call elastic acceleration in a cloud environment or in a on-prem environment, where we are able to add for specific algorithms that are highly computationally intensive an accelerated solution on GPU, on FPGA, on specialized hardware that would enable reducing the total time needed to perform that specific algorithm or function on the computational platform. What does that mean in practice? It means that the time to diagnosis, the latency of the whole analysis, once a patient comes in with a specific condition, throughout the sequencing analysis, and then providing the medical provider with the information, is able to be reduced, enabling, hopefully within, for that specific patient to be able to have the results of the diagnosis within 1 day, to be able to have a shorter latency, enabling more faster diagnostics with that specific patient. So these are the two aspects, and they impact actually the use cases in practice in two different ways, orthogonal or independent ways. In addition to that, we are enabling this kind of platform that we're developing overall everywhere in the world. So we are adding our computational capacity in collaboration with the soft layout we set, for example, to provide data centers close to the customers that would enable them to access our technology locally in their environment. Some of the customers are interested in having an on-prem solution, and in that case we can provide them with a solution that is developed for them on site. And in case some of those customers are not able to have such a solution on site, we are also able to provide them with a solution that is cloud-based, but because of regulation we have to provide that solution actually within a specific geographical region. And this widespread distribution of our compute centers enables us to comply with the regulations and provide that solution locally in the geographical region of the customer. And to bring that all together, we actually provide, in addition to that, a platform, a genomics computational platform that brings high-performance computing, brings customized pipeline analysis capabilities, and wraps it up with security, privacy, and data integrity for the user, and all of this is developed transparently from the user. The issue with the users are basically developers are geneticists or biologicians that have no interest in getting to know the details, nitty-gritty details of the technology that we provide. So with this kind of transparent interface, they are able to use all this wonderful technology transparently for their needs. To wrap it up, I'd like to present a use case that we have engaged with the German Cancer Research Center. Based in Heidelberg in Germany. They have a staff, it's a huge genomics institute, one of the leading in the world. They have a staff of about 2,800 people. They are working now in a number of different international projects, and they are leading in bringing the personalized medicine revolution to the field within Germany. So they are trying to deploy the personalized medicine pipelines to every single cancer patient in the country, ramping up from about 2,000 patients in 2015 up to about 4,000 patients in 2017. And they had an issue, a problem, a challenge achieving this number for their use case. One of the challenge, just I go fast in the challenge, it's a bit technical. They use a specific algorithm. It's called BWMM. It's the first algorithm in their pipeline that enables computation of the location of different genome snippets in a reference genome. Since this is the first stage in the pipeline, this is representing a bottleneck in their pipeline. It uses, at the time, it used 80% of their CPU infrastructure, quite a big chunk of their available compute infrastructure. The issue is that BWMM is a very scalable solution. So you cannot really use more resources in the infrastructure to optimize it and get more performance. It already uses all the infrastructure. The challenge is, with already a fully utilized infrastructure, how are we able to even go beyond that and improve the performance on their infrastructure? So we came up with a number of different solutions with gradual increase in speed up and efficiency. The baseline is an implementation on an Intel Xeon standard server. That would be our baseline, a speed up of 1. We implemented an accelerated version within an Intel environment that achieved with FPGA acceleration 3.5 speed up on their solution. We introduced a Power 8 architecture into the environment to see how much performance we can get by a change in the architecture, and we were able to achieve a 4.4x improvement in speed up, and by adding acceleration on top of this Power 8 solution, we were able to achieve a speed up of 7.8, almost 8 times faster than the standard baseline. Now, what does that mean? Nice numbers. It means that we are able actually to reduce up to 800 CPU hours for every single patient coming in for a whole genome sequencing experiment. By this kind of reduction, we were able to eliminate their BWMM implementation as a bottleneck in their infrastructure and enable them to onboard their new higher performance sequencing machines to be able to go to the next phase of optimizing their platform and also being able to ramp up to treat more patients with their infrastructure. Now, to wrap it all up, basically we are providing a platform that enables integration of high-performance genomics with acceleration, and in addition to transparent application by the user to use these technologies, providing on top of that secure and private data access, and in addition, we are enabling a reduction in total cost of ownership and also trying to help our customers to enable the personalized medicine revolution in the field. Thank you very much.